No, sir.
No. Okay, fine. I will make sure you will get assignments from now on. Okay. Now there are a few things that I want to tell you guys about how to revise the chemistry classes. What do I expect from you guys? How should be the revision? So the revision should be, there will be 3 revisions that you have to do. First is you have to do at least 5 to 10 minutes after class. Okay. Now all of you make notes, right? And you will be using multiple pens, right? At least you will be using 2 pens, 1 pen to write the heading and 1 pen to write the content of the headings, right? Yes or no? For example, if I am studying simple square close packing, then you will write square close packing with a different pen, and then you will write the other things with a different pen. Is that right? Or are you using only single pen? Fatima and Hafsa.
I'm using blue and black.
Blue and black, and most of the people they use blue and black. Okay, fine. Now, after 5 minutes, 5 to 10 minutes after class, what do you mean by that? Is that you will highlight the conclusions. Conclusion. What do we mean by conclusion? For example, I said that the coordination number is equal to 4, and we also said that phase diagonal, its length is equal to a root 2. So these are the conclusions that you have to remember. Okay, so everything that I say that you have to remember these things, then you will, after the class, you will make sure that you start reading, and in 5 to 10 minutes, you will be done with the highlighting part. Okay, so this may take even 15 minutes for sometimes it will take just 5 and 10 minutes. So this is something that you will do after the class. And then 5 to 10 minutes, you try to do this before class. So after today's class, what you will do? You will highlight all the conclusions and all the concluding parts. And on Wednesday before the class, you will take your notebook 5 or 10 minutes before, and then you will just read the highlighted part. Okay, read the highlighted part. Now, this is a very small exercise, but you need to do it consistently in order to get results. Okay, in order to get results, in order to see how it is effective, you have to do it consistently. Now, if you do this for 1 chapter, you will see the results. And I hope after that 1 chapter, you will be doing automatically this for the other chapters also. Okay, so please try not to break the rhythm. And you have done just 1 class till now. This is your 2nd class. After this, please use a highlighter, or even if you don't have a highlighter right now, you just underline those, or you can just make some kind of rectangular shape or something in order to show that it is important parts, okay, that you have to read in before the next class. Now, there's something that you have to do daily. So these are the things that you have to do in the day of the class. There are something that you have to do daily, okay, irrespective of whether you have a class or you don't have a class. Okay, even if you have a class, you have to do this, or if you don't have a class, then also you will do this. You have to do newspaper reading. Have you ever read a newspaper? Have you ever read a newspaper? No, no? Yes, Fatima and Hafsa.
No, sir.
No. Hafsa, what about you?
No, sir.
How sad, na? There is a newspaper. Okay, you have never read a newspaper. Fine. But you have seen a newspaper, right? You have seen people reading newspaper, even in the movies or TV or serials, right? You have seen? ये भी देखा भी नहीं किसी को पढ़ते हुए.
नहीं देखा है.
देखा है ना? अच्छा fine. What do you think? पूरा newspaper पढ़ता है क्या कोई? Do people read the complete newspaper? No, right? No, no. So you know that newspaper, they have headlines, correct? You may have read some snippet of newspaper जो WhatsApp में कभी आ गया हो, कोई खास news होगा तो, right? So there is a headline, correct? ये भी नहीं पता है?
Yes, sir.
You know this, na? Hafsa doesn't speak. Okay, headlines are there. So what you do, you take the newspaper and you read all the headlines, and then you expand on that, and then you read the detail of the headlines, whichever headline interests you. Okay. Now in this case, what you will do, you will read the complete. You will start from the first page of your notebook, and you will just read the topic's name. Don't read in detail, but this is again, you have to do it daily. Okay. So you just read the topic's name. You just read the topic's name. Now there is some topic that, oh my God, ye kab padhaya sir ne? There will be some instances. There will be some instances, if you don't believe me, just open the chemistry textbook or the chemistry notebook of your 11th standard and you start reading the topics. There will be a few topics in which you will be like, oh my God, I have no idea about this. Okay. So what you do at that time, you just read in detail whatever that particular topic is having. So you will do a newspaper reading daily. That means you will read all the topics, the headings, all the topics or the headings. And what you will do, you will read in detail the doubtful parts. Okay, you will read in detail the doubtful parts. Okay, now one more suggestion why I'm saying that you have to read this daily and you have to know the topics daily, because everything is connected in chemistry, right? And in most of the subjects, it is very much connected. Okay, so even if you have this topic, it will be connected with this topic. So once, if your topics are in your head, and if you're reading the topics daily at least, then every topic will be in your head. Maybe the details are not present. Okay, now for example, you have a particular topic, that is the 5th topic, and you're saying, sir, I have doubt in this topic. Now this 5th topic is not independent. It is dependent to 2nd topic and the 3rd topic of this chapter. Now, once you remember these 2 2nd and 3rd topic, at least by name and some context of it, then you will be better understanding the 5th topic. So, but if you don't know the 2nd topic and 3rd topic, you directly jump, sir, mera to bas isi mein doubt hai na? You directly jump with the 5th topic, then you will not be able to understand in much better way. Okay, so please do these things. These are simple things, but you have to do it consistently. And the best way to do this is that you assign some time to it. Okay. Now for this 5 to 10 minutes, it is very easy because you have a scheduled class, and after the class and before the class, you can easily manage it and you don't need any reminder for that. But for the daily newspaper reading, irrespective, again, I'm thinking, irrespective of whether you have a class or you don't have a class. Okay. You have to do daily, have this headline reading. Okay. Now what we have to do, you have to assign a particular time in which you will do the daily readings of the topics. Okay. Is that fine? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. Any doubt? No ना? कर लीजिएगा आप लोग इतना?
Yes, sir.
Okay, fine. Now, wait a second. Okay, fine. So, yes, you can see this, right? So yesterday, just wait a second. So now we have a question: which of the packing is better? So in 2D we have 2 types of packing. Now we have to ask which packing is better in this case. Now for that we have, Acha, tell me, how would you know a student if you have to compare 2 different students? How will you know who is a better student? Fatima, Hafsa, how would you know? We have 2 students, who is better? What will you check?
The marks.
Marks. Very good. So here also we have a similar concept for the solids also. Okay, we have a similar concept for solids also. We will be checking the marks, but that mark is known as packing efficiency. Okay, it is known as packing efficiency. Fine. Now, what is packing efficiency? Acha, what is marks? You can say that if you know the percentage marks, that will give you a holistic idea who is the better student. So, what is how is that correct? How is that calculated? Marks obtained by total marks, right? Yes or no?
Yes.
Okay. Now, similarly, here what we will be doing, here in this packing, since we have got a unit cell and we will be studying the unit cell, what we will do, we will see how much percentage of this is solid. That means these are atoms which are solid, right? And what percentage of this unit cell are the voids. So what we will do, we will just see So you can see that the atoms now, these are marks obtained. These are solids. These are good things, right? And the voids are the marks that has been deducted. So atoms which are solid, what we will see, the space occupied by atoms in a unit cell divided by the total space occupied by unit cell. Okay, so packing efficiency, we also write this as P dot E dot, and this will be equal to, make a line for this. So this is the formula for packing efficiency. You will not remember anything else. Okay, space occupied by atoms in unit cell divided by total space occupied by unit cell into 100. Okay, so here you will get the percentage, right? And in this you will say that whose packing, the solid whose packing efficiency is higher, that is a better solid. Is that clear? Yes or no? Now there is a similar term, that is packing fraction. Packing fraction. Now packing fraction, it is just this part excluding the 100. So if I have this part, this is the packing fraction, and this will give you a decimal number. This will give you a decimal number. Now another thing that is related to packing efficiency is the void percentage. So 100 is the total space, and if I subtract the packing efficiency, that means what percentage of the unit cell is solid, you will get the void percentage. So 100 minus solid will be giving me void percentage. Okay, so please write these three things down. If Fatima is done, waiting for Hafta. Hafta, let me know when you're done. Okay, thank you. So both of you are done. Now write the heading. Packing efficiency of simple square close packing in 2D. Square close packing in 2D. Or this is also known as AAA type. In 2D. Right. So for this, what we will do, just write the heading, don't write anything after this. Okay. So for this, first of all, we have to take the unit cell. So let me take the unit cell. Where is that? Yeah, here it is. Erase a few things. We have got the let me just take this and let this below so that it is here. All of these are touching each other, right? Okay. Fatima, tell me what is the formula for packing efficiency? Packing efficiency is equal to, tell me.
Space occupied by atoms in unit cell by total space occupied by unit cell into 100.
Space occupied by atoms in unit cell divided by space occupied by unit cell into 100. Acha. Now tell me, is this space inside the unit cell or it is outside the unit cell?
Outside.
Outside. So we have to, first of all, what we can do, first of all, let us calculate the effective number of atoms inside the unit cell. So number of atoms in unit cell. Okay, number of atoms that make unit cell is a different thing, but number of atoms inside the unit cell, it is a different thing. Okay, so number of atoms, please listen, don't write anything. Number of atoms in unit cell. Okay, and what I will do, if I get the number of atoms in unit cell, I will multiply it by the area, because here space in 2D will be area. I will multiply this by area of one atom. Correct? If I multiply area of one atom, I will get the space occupied by atoms in unit cell, yes or no?
Yes.
Okay. Now divide by same thing, that is space occupied by unit cell into 100. Now this number of atoms, it is known as Z, into area of one atom. So atom is circle here, and that will be equal to pi r square, hai na? Right? Yes or no?
Yes.
Now similarly, Hafsa, are you not in class?
I'm there, sir.
You there ना? तो कुछ yes sir, no sir कुछ नहीं आ रहा. रोजा लग रहा है आपको? हाँ, Hafsa?
Yes, sir.
You understand Hindi?
Yeah.
You know what does it mean, रोजा लगना?
Sorry?
Do you understand what does it mean by रोजा लगना? रोजा लग रहा है क्या आपको? नहीं. हाँ.
Yes.
रोजा लग रहा है. Fatima, do you understand what does it mean?
Yes, sir.
What does it mean? रोजा लगना?
That the fast is like, it's like hard.
हाँ. ऐसा सिचुएशन है सबसे आपके साथ? You're finding it difficult to speak?
No, I thought you meant. Okay, nothing.
I got it. So you're okay. You don't understand much of Hindi. Fine, no problem. Okay. So you can speak now, Hafsa. So please say yes or no, sir. Okay.
Okay, sir.
Okay. Now, so pi r square and space occupied by unit cell. So this unit cell is a square, right? And its edge length will be a. So what will be the area of this square? Tell me. What will be the area of this square?
4A.
4A is the perimeter.
A cube.
A cube. Race. Area of square. आप लोग को ये रोजा लग रहा लगता है. A square ना? What happened, guys? Hafsa and Fatima? A square, right? Or are you confused? What is the area of square? A square ना?
A square.
A square ना? Okay, fine. So शर्म से नहीं बोल रहे थे अब आप लोग. Okay, fine. So we have to find first of all this Z. Okay. So let me write calculation of Z. So what does Z represents? Z represents the number of atoms in unit cell. Number of atoms in unit cell. So when you have to, please listen to this very carefully. Whenever you have to calculate the Z, you will see first of all how many types of atoms are there in the unit cell with respect to position. What did I say? How many types of atoms are there with respect to position in the unit cell? So in this case, I will tell you, here we have, there are 4 atoms that are present in the corners. I will write there are corner atoms first of all. And then there is one inside the unit cell. Correct? Yes or no?
Yes, sir.
Okay. How many corner atoms are there?
4.
4. Okay. Now, when you have to calculate, see, in Z, we have to calculate the contributions. Hai na? When we have to calculate the contribution, there is 2 different ways to calculate the contribution. Don't write anything, okay? There is one case in which you will look at the angle, and there is one case in which you look at the sharing. So sharing is mainly used for 3D and angle is used for 2D. Okay, because in 3D, if I talk about sharing and if I tell you about sharing, that is an easier way of calculating the contribution, but in 2D, angle is a better way. Okay, angle is a better way. Now, what you have to look, you have the corner atom, right? And what is the angle here? Tell me, what is this angle?
90 degree.
90 degree. And what is this complete angle? 360 degree, right?
Yes.
Okay, that means, can you not say that out of 360 degree, only 90 degrees present inside the unit cell? Yes or no?
Yes.
Now this will give me 4 into, boliye.
I was agreeing.
Okay, fine. Now inside, so we have one atom inside and that whole atom is inside the unit cell. Hence, its contribution will be 1. Correct, Fatima and Hafsa?
Yes.
Hafsa?
Yes, sir.
So that will be equal to 1 plus 1, 2. That will be equal to 2. Now, even if I substitute the value of Z here, that is 2 into pi r square divided by a square into 100. So I know the value that is 2. I know the value of pi, but I don't know the value of r and a. And I cannot even write the values, or I cannot assign any value of r and a because the radius of different atoms will be different, right? The radius of different atoms will be different. So I cannot give any value for r and a now. But still, we want the packing efficiency, and it should be like percentage. Itna percentage, okay, 70%, 80%, 90%. We will get some type of percentage. So how will we deal with this mathematical problem that we have 2 variables and you have to eliminate them? Okay, so for this, I will give you 1 minute of time. Think. You understood? What is the assignment? What is the exercise? What is the problem? Fatima and Hafsa?
Solve.
Solve to karna hai. But you have this r and you have this a, right? Now, if you simplify this 2 pi into 100, you will be still remaining with r and a, r square and a square. Now, you have to eliminate this parts, right? R square and a square in order to get a pure number. Okay, so just give it a thought for 1 minute and then I will tell you how to deal with this. Okay, tell me. So listen here. Okay, so we have to eliminate both of these variables. What we can do here is that we can, if we find a relationship between, please listen carefully, if we find a relation between a and r, for example, if I find the relation, I'm not saying this is the relation, but if I find the relation that a is equal to 2r, okay, or a is equal to some r, right? Then what I can say, I can substitute the value of a as r, and then here also I will get r square, and the numerator also r square, and then we can eliminate r square and r square. That means the next important thing that we have to do in order to calculate the packing efficiency is the relation between edge length A and the radius of atom R. Okay, edge length A and the radius of atom R. Now, for the calculation of Z, you have to look at the positions, right? Position of the atom. And whenever you have to find the relationship between any two things, right? You have to find how much or how effectively, or I can say, how much are they in touch with each other, right? So you have to remember this word, that is touch. Okay. And then you will look at the atoms that are touching each other. So in this case, what you see is the atoms that are touching each other are these atoms. Right? Yes or no?
Yes,
Correct?
sir.
So you will, so this is the way on how to calculate A and R. Okay. So please remember these things very carefully, because we'll be using the same pattern in each and every case for solid. So this is 2D solid first case, then you will have the HCP, AB type, then you will have the 3D solids, 4 cases. In that cases also you will have same things, calculation of Z, then the relationship between A and R, and then the packing efficiency. Okay. So please remember these points very carefully. Now we have got these atoms that are touching each other. Now if this is A and we have this is also A, correct? This is also A. Then you guys tell me what will be the length of this black line. ये आप लोगों ने calculate किया हुआ. You guys have calculated this already.
A root 2.
A root 2, right? Correct. Because it is a square, right? It is a square, and all the faces of a cube, they are also square. So this will be A root 2. Okay, this will be A root 2. Now the distance from here to here will be 1r. The distance from here to here, it will be 2r. And the distance from here to here, it will be again 1r. Correct? Yes or no? Hafsa, Fatima, both of you can see this, right?
Yes, sir.
Okay. So we have got A root 2 is equal to 4r. A root 2 is equal to 4r. Now we will substitute this value, and let me write the packing efficiency. Now we can calculate the packing efficiency. Okay. So packing efficiency, it is equal to 2 into, that is Z into pi r square. This is not a formula. Okay. The formula is this one only. Space occupied. Please remember this formula only. Don't remember these small formulas. Okay. These are specific formulas. 2 is the Z for A type. That is why this is 2 here. Pi r square divided by A square. And then we can write what is A. A, it is equal to 4 by root 2 r. So you can write this as, okay, wait a second. I have to multiply 100. I always forget this 100. So I'll get that 2 into pi into r square divided by 4 by root 2 r whole square into 100. And you can write 2 into pi into r square divided by, you will get here 4 square divided by root 2 square will be 2 into r square into 100. So you start writing from here. So did you guys write these parts? लिख लिया ना आप लोगों ने? हमने मना किया था फिर भी?
Not, I didn't write.
You did not write. Okay, fine. लिखिए फिर, है ना? Start writing from packing efficiency of SCP 2D. ये type in 2D. Heading लिखा है आपने फातिमा? Did you write the heading?
Yes,
Okay.
yes.
Okay. Both of you are done, but please calculate this packing efficiency also, Anna, and send me in chat what is the answer for this. Solve this down. So you'll put this 2 over there into 2 into pi into, oh no, you can eliminate these r square, obviously. You get pi here divided by 4 into 4. So you can cancel this into 100. These 4 by this 4, and you will get pi by 4 into 100. But please calculate what is the exact value for pi by 4 and then multiply it by 100. You can take the pi's value as 3.14, or you can also take it as 22 by 7. Send the answer in chat, guys. What happened? Calculate कीजिए. Pi by 4. Yes, correct, both of you. Fatima and Hafsa, 78.5%. Okay. Now you can write a few more things down related to packing efficiency. And those things are the packing fraction, which will be equal to 0.78, because to just remove the 100, you will get 0.78. Then the void percentage. What will be the void percentage? This is 28, so it will be 21.5% is the void percentage. Okay, so please note down these 2 points. And so we have discussed the packing efficiency in square close packing. Now it's the time for the packing efficiency in hexagonal close packing in 2D or ABAB type. We have got the hexagonal close packing. Let me also draw the this is our unit cell. Yeah. Again, packing efficiency is going to be the same space occupied by atoms inside the unit cell divided by the total space occupied by the unit cell. Okay. So for that, first of all, we have to calculate the Z. Okay. So first of all, calculation of Z. Now, Fatima and Hafsa, you guys tell me how many types of atoms are here with respect to their positions? How many types of atoms are there with
6. 6.
9 according to their position. जाइए पिछले वाली में जाइए आप calculus packing में जाइए, then look at the calculation of Z and then think about it. I've asked the same question and I answered at that time myself. अभी आप लोग जवाब दीजिएगा. How many types of atoms are there with respect
4.
to the position? 4, Hafsa. Okay, tell me what type of atoms are there? How 4? You're saying 4 types of atoms are there, na? What is the first type of atom? Tell me. Go to square close packing. In that, go to calculate. Corner atoms are there and
Inner.
Inside atoms are there, right, Fatima?
Yes.
Hafsa, can you see that now?
Yes.
So with respect to the position, we have 2 types. Corner atoms. How many corner atoms are there? Tell me.
6.
6 corner atoms are there. Okay. Now, each of these corner, what is the angle here? What is the angle here? This is a regular hexagon. Guys. What will be the angle?
60 degrees.
What will be this angle?
90.
90 na? This is greater than 90 na? 60 कैसे बोल देते हैं? What will be the angle? What will be the angle here? 120 divided by 360, correct? This whole angle will be 360. Out of that, 90 is present inside the unit cell, Anna?
Yes.
Okay, so this will be equal to 6 into 1 by 3, which will give me 2. And there is one atom which is inside. Hafsa, aapko aa raha hai? Are you understanding these points? Yes or no? There is one atom.
Yes, sir.
Okay, so Z will be equal to 2 plus 1, which is equal to 3. Okay, so we have got the Z. Don't write anything. Let me explain the next thing, that is the relation between A and R. Now you guys tell me, I'm numbering the atoms 1, 2, 3, 4, 5, 6, 7. So tell me which are the atoms that are touching each other that we can take to calculate the relation between A and R. Which of the atoms should I take out of these 6? I mean, out of these 7? Remember in the last case, no? In the last case, how did we do that? What will we be doing here? Bataiye. Which atoms should I take to calculate the relation between A and R? You have to look at the atoms that touch each other, na? Tell me. अरे बोलिए क्या हुआ? The atoms that are touching each other. Fast. Hi.
A is
A अरे A कहाँ, हमने बोला which of the atoms are touching each other, name numbered the atoms also है ना. अब उसमें आप बोल रहे A B, I numbered it 1 2 3 4. खैर, so this length is how much? This length is A, right? Edge length. This is R. This is also R. Hafsa and Fatima.
Yes.
So A is equal to how many R's? Tell me.
2R.
2R. Very good. Now the third thing is the packing efficiency that we will calculate. So please remember, packing efficiency is space occupied by atoms inside unit cell divided by the total space occupied by unit cell. So atoms inside unit cell, Z into pi R square, that is the area of one unit cell, divided by. Now what is the area of hexagon? Area of hexagon? G.
C root 3.
C? C क्या होता है? बोलिए बोलिए, C root 3 बोलिए बोलिए.
3 root 3.
3 root 3. अरे इसमें तो A में आप कुछ ला ही नहीं रहे. Listen, you will not be knowing the area of hexagon. So rather what we will be doing, we will be distributing this hexagon into equilateral triangles, as you will see. Okay. Can you see that we have got 6 equilateral triangles? Yes or no?
Yes.
So what we can do? The area of one equilateral triangle is root 3 by 4 A square. You guys remember? And then we will multiply this by 6 in order to get the area of whole hexagon. Fine? Yes or no?
Yes, sir.
Okay. Now you need to just replace this A square by 2R in order to calculate the packing efficiency. Z into pi R square divided by 6 into root 3 by 4. A square will be 2R square, that will give me 4R square, right? 2R whole square, that will give me 4R square into 100. You can eliminate many things, R square, 4 and 4, and then you can calculate this thing. Okay, so Z you can also write 2. Z को हटा के यहाँ पे हम लोग, sorry, Z यहाँ पे 3 है तो 3 लिख दीजिए. So please write this down and then calculate the packing efficiency. Okay. When you are done, send the answer in chat. Fatima, can you ever score that many marks? Fatima, can you score that much marks? That much percentage?
No.
No, no, it's not possible, right? It should be less than 100. Try once again. कुछ कहीं पे mistake कर रहे हैं आप, nothing else. So what is the value of root 3 that you are taking?
I didn't calculate root 3. I forgot to calculate root 3.
तो फिर क्या किया आपने?
Forgot to calculate root 3. I did 1 by 2 into 100.
1 by?
1 pi divided by 2 into 100. I forgot to multiply.
Actually, you forgot to multiply, na? Okay, fine. So pi divided by 2 root 3 into 100. So you know value of 2 root 3, yes or no?
Yes.
No.
Because
No.
3 and 6 get divided.
What, Fatima? What's the value of root 3?
You're asking the value of root 3. I thought you.
root 3 value. क्या होगा?
One.
Only one.
1.7.
7.
3.
3. कहाँ से देख के बताया आपने?
I know.
You know. Okay, fine. अच्छा. Hafsa, you also calculate. Hafsa, आपका आंसर नहीं आया? Okay, calculate कीजिए, आप calculate कीजिए. आप calculate कीजिए आराम से. Yes, Hafsa, correct. Fatima, what happened? आपका आंसर नहीं आया. Pi divided by 2 into root 3. Yes, Fatima.
Yes, sir.
नहीं आया आंसर अभी तक?
नहीं, sir.
Yes, ही आ रहा. Write the answer 90.6%. Okay, 90.6% will be the packing efficiency, and then you can write a few more things. That is packing fraction, which will be to 0.9, and then you'll write the void percentage, which will be equal to how much? 9.4, right? Then please write these two things. Then we will look at the 3D ones. Okay. So moving forward, let us suppose you got a question which is asking you write the differences between square close packing in 2D and hexagonal close packing in 2D. So what are the points that you can write? First of all, you will draw the picture of both the packings, right? Atoms under atom and atom under depression. Then as soon as you draw the picture, you will identify the void. Third thing that you will identify is the coordination number. Fourth thing that you will see is the unit cell. Okay, so you will say that in one case the unit cell is going to be hexagon, in the other case the unit cell is going to be a square. Fifth point that you will do is that you will write the we have got picture, we have got the void, we have got the coordination number, we have got the unit cell, right? We have got the unit cell, then you will write the packing efficiency, right? You can also write the packing fraction and the void percentage in one go, and the void percentage in one go. What else can you write? You can sixth, you can write whether it is AAA type or it is ABAB type. What else can we write here? We have got picture, we have got void, we have got the coordination number, we have got the unit cell. Then you can write the Z for each of them. You can also write the relation between A and R. Okay, so you can see that there are at least 8 points that you can easily write. There are 8 points that you can write. Now this is in the order of their priority. So if you don't remember anything, you just write the picture. Then you write the void. Then you write the coordination number. Then the unit cell. Then the packing efficiency. Okay. So remember it in this way. Please write this down. Raise your hand when you are done writing these 8 points. Okay. So just write the points. You have already drawn the picture, the void, the coordination number, the unit cell, and etc.
Done. Done, sir.
Okay. Okay. What's that done?
No, sir.
Okay. And now, what's up?
Yes, sir.
Okay, fine. So we have looked at 1D packing till now. Okay. And after that, we looked at 2D. In 2D, we got two different type of cases. One was square close packing in 2D, and the other was hexagonal close packing in 2D. Now what we'll go to 3D, but we'll take the base of square close packing and then we will go to 3D. So you know that square close packing is going to be this one. Atoms under atoms, right? Now what I can do, I can place another atom just on the top of this atom, or so I'm adding height now. Okay, so we have laid these atoms on the floor and then we are adding atoms. So we are adding height here. So what I can do, I can just put an atom over atom, or what I can do, I can put an atom over the void that is made by the square close packing. Okay, so when I go from square close packing to 3D, then also I am getting two parts, atoms on atoms, and the other is atom on void. Okay, atom on void. So first of all, we will look at this atom on atom case, then we will look at this atom on void case. So let us first of all write atoms on atoms in 3D. So we'll be looking at atom on atom in 3D. Atoms on atom in 3D. Okay, so please remember that the base is going to be square close packing, but as soon as I make these circles here, these are no longer circles. These are, what are these? These have become sphere, right? Very good. So now what you can imagine, you are laying a floor full of footballs. Okay, floor that is full of footballs like this. Now what we will do, we will just lay atoms on top of these atoms only. Okay, so you can see when I will lay it like this here. Now wait a second, I will also show you guys in 3D. Yeah, can you guys see this? Tell me yes or no.
Yes, sir.
Okay, so see, this is the first layer that we have put, right? And on top of that, I am putting another layer. On top of that, I will be putting another layer. On top of that, I will be putting another layer. So sequentially, we will be building up the packing like this. Okay, so first of all, we have the first layer. Then we have got the second, atoms on atoms, atom on atom, atom on atom. Got it? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. So moving back, so I have placed these red atoms a bit slanting like this. Okay, so that you understand these red atoms are on top of the black atoms. Now we will look at the unit cell. So for unit cell, what I will do, I will take this set of atoms. So I am taking the black atom that is present in the lower layer, and I'm taking the red atom that is present in the upper layer. Okay, so let me take the black atoms like this. So wait a second, इसमें ऐसे करते हैं, इसमें ठीक बनता है। So we have got the black atoms in one layer. Then we have got on the top layer, we have got the red atoms. And then I'm going to join them. Okay, so as I join them, you can see that we have made a cube, right? Yes or no? Correct? This is a cube.
Yes,
so this is a unit cell for this packing. Okay, this is the unit cell. Also, we can also say that this black layer is the layer A. Then this red layer is also the same layer A. Then again, we will have again a layer that will be also layer A, because all of them are atoms on atoms. They are indistinguishable. Okay, they are indistinguishable. So let me write it here. This is A type in 3D. Oh, sorry. A type in 3D, and the unit cell is what? Simple cubic. You guys remember voids? You guys remember voids now? Yes or no? Tell me.
Yes.
3D void. This is one of the voids now. What is this void? Tell me. What void will be present? What is the name of this void?
Cubicle
कौन सा
void.
void होगा यहाँ पे? Cubical void. और देखिए कितना आसान है. Let me also write the calculation of Z. Okay, so in this, you tell me, in this unit cell, all the atoms are in corner, yes or no?
Yes, sir.
All the atoms are in corner. So we have corner atom. How many atoms are there in corner? Tell me.
8.
8. What is the contribution of each corner atom? First class से पढ़ाया है हमने. What is the contribution of each corner atom?
8.
1 by 8. So this is going to be equal to 1. Hence the Z is equal to 1. Second point, that is the relation between A and R, right? Relation between A and R. So you can see that here we have this length is A, right? This black atom and this black atom, they are touching each other. You can see in the down floor, right? In the lower layer. And that is why what you can say, this length is A and this is R and this is R. Hence A will be equal to 2R. Can you see that A is equal to 2R? Do I need to explain it more? No,
No.
Okay, fine. So you write all of these things. Okay. And I will do my iftar, pray my maghrib, and then when you guys are done, you can just leave. Will that be fine?
Yes, sir.
Okay, fine. Thank you guys. Thank you very much. Bye bye. Take care. Huh? And please revise. जैसे आज viva हुआ है, you will have the viva, similar viva on Wednesday also. Okay. And I can ask about anything from this class and from the last class also. So please revise. Okay. Chalo, bye. Take care, guys. Thank you.
Thank you, sir. Bye.
Thank you.